Hey guys, Mr. Backerberg here. In this video, we're going to look at infinite limits as x approaches a. So if the values of a function f of x grow boundlessly as x approaches a specific a value, then we can say that the limit as x approaches a of the function f of x is either positive infinity or negative infinity, depending on if you're growing boundlessly up forever or if your graph is going down forever. So what we're going to do is we're going to look at the graph of the function f of x equals 1 over x, and we're going to look at this as x is approaching 0. Now it's not actually safe for us to plug 0 into this function because 0 is not in the domain of this function, since you can't have 0 on the bottom of the fraction. But we're going to look graphically at what happens as we approach 0 from each side. So in my calculator, in the y1, I've got 1 over x typed in. I'm going to do zoom 6 to get my nice 10 by 10 window. And we're focusing on that x value of 0. And what we've got happening here, if we approach 0 from the right-hand side, this graph starts going up forever and ever and ever. And as we get close to that y-axis, my calculator has trouble graphing it out, but this graph would keep extending up forever along that y-axis. And if we approach 0 from the left-hand side, our graph is dropping down forever. And again, we've got the same kind of behavior with the graph looking like it ends, but it does in fact trace this y-axis down forever and ever and ever. So as we approach 0 from the left-hand side, our graph is going down forever, down to negative infinity. And as we approach 0 from the right-hand side, our graph is going up forever, all the way up to positive infinity. So what's happening in here, our graph is showing that behavior because it's got a vertical asymptote there. So the line x equals a is a vertical asymptote of the graph of your function if either the limit of your function as x approaches a from the left-hand side is either positive infinity or negative infinity, or if the limit of your function as x approaches a from the right-hand side is positive infinity or negative infinity. If, as you approach that specific a value from either side, if your graph goes up to positive infinity forever or down to negative infinity forever, then there is a vertical asymptote at that specific a value. So in this example, we're going to look at finding the vertical asymptotes for the function f of x equals 1 over x minus 2, and we're going to describe the behavior on the left side and the right side of any vertical asymptote that we find. So we're going to use our calculator to help us out. In my calculator, I've got that function typed in, 1 over x minus 2. I'm going to hit graph, and I'm looking for any place where my graph goes up forever or down forever. And what I'm focusing on in my picture here is this vertical line that would be happening at the x value of 2. As we approach 2 from the right-hand side, my graph goes up forever, up to positive infinity. And as I approach 2 from the left-hand side, my graph is going down forever. So that specific behavior as we're approaching 2 tells me that we have a vertical asymptote at 2. Now, if we go back to the function, we should recognize that we're having this behavior happen at that x value of 2 because 2 is not in the domain of this function. Because if we tried to plug in 2, we would get 0 on the bottom of the fraction. So we've got a vertical asymptote happening at the x value of 2. So that's the vertical line, x equals 2. Now, if we look at describing the behavior on the left side and on the right side. So if we look at the limit of our function 1 over x minus 2 as x approaches 2 from the left-hand side, there our graph was going down forever and ever, so we would say that this limit is equal to negative infinity. And then if we approach from the right-hand side, so if we do the limit of our function 1 over x minus 2 as x approaches 2 from the right-hand side, the right-hand part of our graph was going up forever, up to positive infinity, so this limit is equal to infinity. That's going to be it for this video. Thanks for watching.